Hello, everyone, and thank you for joining us for today's webinar. It's both a bonus session in our 2021 Climate Action webinar series and a special member benefit opportunity for AIA California members. My name is Bob Murren, FAIA, and I am this year's AIA California Secretary Treasurer, and I'll be your moderator for today's segment. As you know, AIA California has developed a series focused on understanding and implementing the AIA framework for design excellence, and will continue through the end of the year. All webinar content and additional resources will be available on the AIA California website following each session. In partnership with cove.tool, we are excited to provide access to powerful tools that help our members and member firms overcome hurdles, streamline processes, and improve the delivery of your architectural services. A few quick housekeeping reminders before we get started. Today's session qualifies for one AIA learning unit for those watching live, and the AIA California staff will report those units for you. The session is also being recorded and will be posted on the AIA California website. Following today's webinar, make sure you take advantage of the special offers that cove.tool is providing specifically to AIA California members, including a 4-week complimentary cove.tool license and additional support. The deadline to participate is at the end of the month on April 30th, 2021. As a reminder, please use the Q&A function in Zoom to ask any questions of today's presenter. You can also like a question to move that question to the top of the queue. Now on to today's webinar. Today's session is brought to us by cove.tool co-founder Sandeep Ahuja. Sandeep will discuss how shifting energy codes are challenging architects with a wide array of parameters to balance, like energy, cost, daylight, views, and embodied carbon. Many architects are harnessing simulation to shape the design and detail of their projects. To be successful, teams must understand the levers that impact the performance and set up processes for success. We will dive into 2 case studies to generate beautiful analysis graphics and see how to shape the narrative in a data-driven design process. I would like to quickly introduce today's presenter before handing things over to her. Sandeep Ahuja, co-founder of cove.tool, brings her experience of working on over 200 high-performance projects. Most recently, Sandeep presented at the UN Environmental Assembly with 1,500 global delegates on the impact of buildings on climate change, showcased at the TEDx Atlanta, and won the Forbes 30 Under 30 for developing cove.tool, an automated sustainability consultant. With her desire to bring automation into the AEC world, she is pioneering the integration of data-driven thinking into the design and construction process by developing an intelligent software. Sandeep, please take it away. It's all yours. Welcome.
Fantastic. Thank you for that warm welcome. Hi, everybody. It's such a pleasure to share some of what I have with me today. High level, what I want to do is talk a little bit more about building performance modeling, what it even means, what are some of the key metrics that we should all be aware of as we're going out to pursuits, as we're having our design presentations, as we're presenting information to owners, and how we can keep all of that integrated. By the end of the session, we'll all have actionable information to not only understand, but also be able to run a lot of these simulations as part of our process. Like Bob mentioned, with cove.tool, we'll be able to showcase kind of how to do that. And I am currently sharing my screen, and I wanted to make sure that y'all can see it. And we'll be able to go through all of the various types of analysis within the next 20 to 30 minutes instead of something that would have typically taken 3 to 4 weeks. And not only will we run through the simulations, we'll run through what to do with this analysis, what to do with this information, how does it impact our design, and go through case studies that have done exactly that to see how it shaped those particular designs to give actionable information to your projects and pursuits. So on a super high level, why is this important? This slide becomes less and less relevant to members, perhaps in California, as I would think, being located myself in Georgia, but I find it always critical to just keep bringing it up. The fact of the matter is that buildings do account of all carbon emissions. And in cities, for example, city of Atlanta, where I'm located, this number is closer to 60%. City of New York, this number is closer to 70%. All to say that everybody that's on this call, all architects, engineer, design community, we have an outsized ability to impact the entire carbon emissions conversation. Just in case that's not enough to get our juices flowing, owners are requiring this on pretty much most of their projects. In a survey conducted last year of 1,000 architects in the United States and Canada, it was revealed that a majority of RFPs and RFQs are now requiring building performance, are requiring sustainability to be some part of it. And of course, the easiest way to do it is to just start doing it so that we don't have to start figuring out how to incorporate building performance when we see the RFP so that it can be a part of our workflow. We can already be prepared and we can go out and start pursuing some of those projects as well. And lastly, but definitely not the least, our building regulations are becoming more and more stringent. The graphic that we see right here showcases basically how the building energy codes have been becoming more and more stringent for the last 30 years. The same building that could once use up to 100 EUI can now only do 20. EUI is one of the most common metrics that we'll all keep hearing if we haven't already heard. It's the energy use intensity. It's the amount of energy a square foot of your building uses over the course of the entire year. If you've ever heard something like net zero building, a lot of times it's talking about net zero EUI. Sometimes it's talking about carbon, but a lot of times it's talking about net zero EUI. So as the building energy codes become more and more stringent, the likely understanding is that our buildings are going to become more expensive. This is exactly what happened in Atlanta last year. We went from the ASHRAE 2007 to the ASHRAE 2013 code. That's a 40% drop. And I know a similar thing happened with the latest version of California Title 24 being released. When new codes come out, our buildings tend to get more expensive because we have to put better glass, better mechanical system, better wall insulation, better roof insulation, so on and so forth. That's exactly what we're going to optimize today as well with cove.tool. We'll figure out the absolute lowest cost way to start hitting some of our building performance targets, whether they're just meeting code minimum or they're even more ambitious to pursue things like Living Building Challenge, LEED, Green Globes, and other green certification metrics. Now, here's a typical design cycle. Everything from pre-design all the way to operations. As you can imagine, our ability to impact the cost and the building performance of any given project is really high up front. Nothing shocking there. Nothing is quite fixed. Nothing is quite set in stone. So we can change it easily. Of course, because we can change it easily, that also translates to cost of design changes. It's pretty low. Imagine having to make complete massing changes all the way at the 50% construction drawing phase. That's a very expensive change because we have to coordinate that across all the consultants, all the sub-consultants. Despite the fact that that is the most expensive stage to make any design changes, that is where a lot of traditional building performance modeling happens because it's not to inform the design, it's merely to hit a checkbox to see if we met it or didn't meet it. And if we didn't meet it, oh boy, the design changes and the cost of those changes, it's not cheap. Of course, with building performance modeling shifted earlier on, as we're going to see today, we can start making all of those decisions as early as pursuit, pre-design, concept design, schematic, so that by the time we make it to the construction drawing phase, there's no room for guesswork. We already know exactly where we're headed, and that increases our profitability by 6%. And when we're getting paid in a lump sum, which 2/3 of us are, that's a really, really big deal. Now, before creating cove.tool, I ran a successful sustainability consulting practice. And in this consulting practice, me and my team worked on just about every project type that you can imagine. everything from multifamily, labs, retail, healthcare, hospitality, single family, everything on the table. And what we realized was that no matter the project type or the project size, we always had to do a few core pieces of analysis to get started, to really make sure that the project was optimized for building performance. We always had to collect climate information so we could really understand the location that we were in. Always had to do some benchmarking so we could compare our project to the rest of the country or the rest of the world. We had to do some conceptual energy modeling so we could understand where our project landed in terms of that benchmarking, do parametric runs, and then follow that along with daylight, glare, shadow studies, carbon, water studies, so on and so forth, and pull everything together in a nice, easy to use report. Whether you do some part of this, all of this, whether you have consultants that do this, no matter how you're handling this right now, it's a very time consuming process. And it took our clients anywhere from $32,000 to $38,000 for a simple 75,000 square foot building. Of course, in the next 20 minutes, we'll see how we can automate most of this and do all of this in about 20 minutes. So let me hop on over back to the actual website. Of course, just in case you haven't already, definitely feel free to create your Cove tool free trial. As part of the partnership with AIA California, we're offering an additional, because the standard trial is 2 weeks, we're expanding that to 4 weeks. You can click on this button and simply send the certificate of this particular event to hello@cove.tool.com, and they'll expand your trial duration to 4 weeks so that you're able to have that complimentary access for the entire month. Of course, with the deadline for AIA 2030 reporting coming up soon as well, it times well. So in case your firm is a signatory to the AIA 2030 DDX, you can auto report, you can use your complimentary month of license to report all of your projects, because it's very, very possible. So once you do that, it will bring you to a screen that looks just like this. So let's actually go ahead and do this. We describe who we are on a given project. I'm an architect. You describe how much experience you've doing any performance modeling before. Let's say I've never done this before. I'll go ahead and I'll select my company size so the platform can curate itself to be best fitted for you. Let's say I'm a 1-person firm, or maybe I'm a 1,000-person firm, or somewhere in the middle. It doesn't matter. The platform will configure itself to best fit your needs. And at this point, I can either explore an example project or start creating a brand new one. Let's actually create a brand new project from scratch today. So I'm on the main project homepage. Here we are. And right across the top, you can see the AIA 20-30% reduction. So if you've never heard of AIA 2030 commitment, definitely check that out. Of course, you can Google it, or you can touch the help icon, which will take you to the internal Cove Tool Help Center, which is basically Google for building performance. And you can type that in there and understand exactly what AIA 2030 commitment is, what it's striving for, and how you can automatically report all of your firm's projects using Cove Tool, something that would have taken previously 2 to 3 weeks of a person's dedicated time pulling it together in a spreadsheet, uploading it, all that good stuff. So you can truly automate it without it being a major time commitment for your team. You're also able to see what all of your different projects are in terms of their performance cycle, which projects are doing well versus which projects perhaps need a little bit more attention, so that we can go ahead and update those and apply some of those performance strategies. We can also see a quick map of where all of our projects are located. Of course, if your projects are more geared towards one specific part of the country or the world, you'll see a much more zoomed in version of this map. At any point as you're modeling your first projects, because we understand that as an industry, we're all taking the next steps. We are partners to you in your education journey as well. You can use the chat window, which is composed of experienced mechanical engineers, architects, and performance modelers, to ask all of your questions, whether they're basic questions on how to start modeling your first project, which of course you can also find in the Help Center, or they're advanced questions where you're not entirely sure how to model a specific mechanical system type. No matter what the question is, you'll have a response in about 5 minutes, so they're an extension to your entire technical team. You can see that every project is listed as a tile. So for each project, I have the project name, project number, square footage, EY, and who worked on it. So if I'm collaborating across my team, let's say I'm located in Atlanta and I'm collaborating with my fellow designer who's in Los Angeles, I certainly can. And if I don't want to be the annoying person who constantly keeps asking, how far did you get? How far did you get? I can simply create a report and see how far they got, because we're all tied into the same web app and are watching the same real-time version of the actual platform. At this point, we can actually go ahead and start new project. I can do so simply by clicking here, which says Start New Project. And the moment I do that, it brings me to the project creation dashboard. On the left navigation bar, I see a whole range of icons. The key thing to note is that the platform needs 2 pieces of information from you: basic project information and geometry, and everything beyond that point. All of the different performance analysis types, which we will go over in just a second, all of the different metrics, all of the different items, all of the different snapshots are automatic, and we'll be able to get those in return. So I'll go ahead and I'll give it a project name. I called it Education Project. I'll give it a project number if you have one. I'll invite my entire team to it to collaborate with me, whether internal to my firm or external team members, so we can collaborate together on the project. I'll go ahead and I'll type a project address. Because I'm not based in California, I typed in the address that I have to go quite typically when I'm in San Francisco for meetings. So I said 1 Market Street, San Francisco, right here in the Google map, and it popped it up. It's right here. The moment I did that, it automatically picked the California Title 24 2019 code for me because it knew that's what is prevalent in that location. Now I can downgrade it if I want for whatever reason, but it will automatically pick the local energy code for me. At this point, I'll move on step 2 of 2 by simply clicking here. It will bring me to a screen that looks just like this, where I'm bringing in information to the platform. Now, if we have a 3D model in any of the various 3D modeling platforms that exist, whether it's Revit, SketchUp, Rhino, Grasshopper, ArchiCAD, I can bring in the geometry directly from those platforms as we have plugins to every single one of them. If we don't have 3D geometry, we can create some on cove.tool as well, and I'll show you how to do that in just a moment. If we don't want to create a geometry and just want to get a high-level overview of what's going on, we can also just type in area takeoffs and also have a good model going. So tons of possibilities over there. If I wanted to bring in my model directly from Revit, for example, I could simply pop open the Revit file. Once the plugin is installed, hover on over to the actual plugin, select the correct project, click on the button, Create cove.tool Views, which creates these custom views in the 3D views category for all of the various elements that are critical for a good building performance model. Key elements that are needed for a good building performance model are your roof elements, your wall elements, your floor, and your windows. That is the bare minimum, the items that we would have as early as the pre-design stages. Now, if we have more detail, if we have interior walls, if we have skylights, if we have shading devices, great. If we don't, there's no reason to wait. There's never a reason to not do a performance model, because with every massing, with every fenestration that we're drawing, with every shading device that we're drawing, with every placement that we're doing, we're making a decision, and would rather use a data-driven way to make the decision instead of not. If everything looks good, you're able to simply hit export all, and all of the geometry shows up directly in cove.tool. And we can see it right here as it's loaded up, and the 3D button is now active, and we can hit go to daylight. The moment I click that, it spins for a few minutes, and then it shows up. As you can see here, we didn't model any of the context geometry, but it's all here. So here I am on that one site. I actually demoed an existing building to put my building that I brought in from Revit right here. You can use the edit icon to move or rotate your building, or to edit or remove any of the contextual buildings if they're no longer, if you're demoing them as part of your design. You can also see that all of this urban context is auto-modeled. So if you've ever, like me in my previous life, outlined your context, extruded it, spent 8 to 12 hours getting a good context going, well, you no longer have to, because it's entirely automated. I'm going to go ahead and hide the text because I find it a little bit distracting. I can see here is my project brought in, and here are all of the various analysis type. We're currently looking at shadow analysis. This analysis type is a key analysis type for pretty much every single design project. I would use it as a consultant or as a designer for a few different reasons. I'd use it to figure out how the shadow moves across the day, across the month, across the year, across my site, to understand what parts of my facade, what parts of my massing are going to be in shade, and what parts are going to be exposed. It's also helpful to understand if I am planning perhaps an outdoor patio and I want it to be in sun, well, I can make sure that I don't put it in a place that's constantly shaded, like right here. So definitely immensely, immensely helpful analysis type for just about every project. If I'm using this to tell a powerful design story, I can certainly move it to the time of the day that I want to set it at and hit the camera icon. The moment I hit the camera icon, we can download a high quality PNG for our use to introduce as part of our presentations or our presentation boards. Another type of analysis that I find immensely helpful is the radiation analysis. This is basically the maximum solar potential in kilowatt hours per square meter. So I can see right here how the sun falls in different parts of my building. So I can see right here what parts of my facade have hot spots, if any. I can see where there's not enough access to solar and where there is access to solar. As an example, if I was perhaps wanting to put some photovoltaic panels on my building, I would know that putting it here is just not a good idea because it's it's in shade for a good bit of the year from these buildings, and my solar potential is medium. It's not high. We don't have any part of the roof that has high solar potential because it is in such a dense urban context. However, these edges are definitely higher than kind of that middle zone. So it can help us really figure out and prioritize where it is we even want to put some of those solar panels and where they even will be effective from just a pure massing standpoint. Another analysis type and metric that is very helpful is the sun hours analysis. We can use it in a few different ways. We can use it to figure out which parts of the facade have access to daylight, since daylight is such a critical part of making sure that, that the occupants enjoy a space, experience it well. As you can see, I have tons of daylight falling on me. I can hardly be operational without good daylight. And that's true of a lot of people. So if we do have a fixed budget and we can only punch 30% glazing, or we can only put in 30% window to wall ratio, we can make sure that we're optimizing it, that we're putting it in locations that even have access to sunlight hours. Another way that I can use this particular analysis is to make sure that if I'm collaborating perhaps with the landscape designer, that we're only putting the plant species on the roof. For example, this part of the roof only gets 6 hours a day of access to sun. So I'd only put species that are going to do well in that particular location type. I can see a few questions popping in. Once I run through the platform and some of the metrics and the case studies, I will leave 15 minutes before the top of the hour to go through every single one of your questions. So if your question came in first, I'll answer it first. And if it came in last, I'll answer it last. Of course, if you're wanting to, again, introduce this as part of your overall story that you're telling, you can even hide certain context and just click a high quality PNG and get it going. Another aspect that's especially critical in early design is getting all of your zoning information. So you can see all of the property lines built in, along with the land value, who owns that land, what's the zoning for that location, all built in one easy to use location. One feature that I find especially helpful for design is views. So let's click on it and go to a 2D view. So we're on the top view and north is now facing up. So let's zoom into that and see what the view quality analysis type even means and how we can incorporate that for our projects. Now, the view quality analysis type is especially helpful and especially critical for any building that we want to have high value in. Just like daylight, buildings that have high view quality, that have a good view where people can see out, typically also have a higher real estate value. I mean, imagine even for multifamily apartments that have a good view to the outside, rent for more. Hotels, rooms that have rooms to, views to the outside, rent for more. We always get our, mountain view or pool view are always priced higher. The same translates across many other building types. So you can actually see deeper the blue, the better the view. If it's gray, it doesn't have any view at all, just in terms of these metric. Of course, if this is also a project that's pursuing certifications like the LEED certification, you can see whether it would pass or fail the credit. In this case, we would get that point for LEED views. The views are composed of 3 different view types: sightlines, sign, context, and unobstructed. And you can see each of those and also look at it floor by floor to see exactly where you need to modify things. Perhaps you need to add some additional windows. Perhaps you need to put the desks, if this is an office space, where there is a view. Another type of analysis that you can see right here is the daylighting analysis. This is the spatial daylight autonomy, basically the quantity of daylight. Orange is good, blue is not so good. And we can see from right here what the daylight penetration looks like. So we don't have a whole lot daylight coming back here, even though we have a pretty good daylight penetration at the front. We can see that on a floor by floor level, and we can see our overall 33% SDA. The minimum required SDA as defined by some of the benchmarks is 50%. So this building is not doing too well in terms of daylight. So if we catch that early on in our massing stages, in our schematic design phases, well, we can fix that. We can add more glazing. We can make sure that the glazing that we have is oriented appropriately. Another analysis that's especially critical and a metric that's especially one that we should all just know and have on our fingertips is the ASE. This is the annual solar exposure. It basically is the number of hours a particular part of the floor plate, if a particular floor plate has over 1,000 lux, which is considered too much glare for more than 10%. So we can see right here, yellow is considered okay, green is great. So we do have some glare related challenges right here on the southeast. So if we did want to make sure that our facade was optimized, well, we wouldn't put shading devices everywhere. And if I had to, again, manage a really tight budget, I would know that from a shading standpoint, my priority number 1 is this facade right here. Priority number 2 is that facade because it has some mustard, you know, the deep yellow color. Priority number 3, this facade right here. And then everything else can basically get away without having any shading devices at all. So really, really helpful to have that information built into your design process. Now, if we didn't have a 3D model, we could have also drawn it. So right here, we had 2 opportunities. We can either go to the drawing tool, which is exactly what this is, where you can go ahead and draw your geometry from scratch to at least get your high level massing going. I can go ahead and draw, you know, all kinds of walls and shapes to really start representing my geometry well. This doesn't look like a good mass, but hopefully you'll draw a mass that makes a whole lot more sense than this one did. And you can add doors and windows and openings. And just in case you don't already even have a 3D model and you're just getting started, you're really in that thought phase, you can certainly use the drawing feature to be able to draw and represent your massing. Once we've done all of the analysis, we can move on to understanding the energy use intensity for our project. This is a quick glance at what the whole building EUI is. We talked about EUI as a core metric, right? Energy use intensity. We can see how many potential LEED points it will get. In this case, none. We can see exactly what the operational carbon reduction is for this project. In this case, we're reducing it by 82%, which is really fantastic. And we can see benchmarking, what a baseline building of this would be like, where we're at, and what the 2030 target is. So in this case, we have achieved the 2030 target with some of the modifications that we've made. All of these inputs right here. Of course, we can collaborate with mechanical engineers and consultants who are invited to the project, but it gives you a really fantastic starting point because it's automated for your local regulations. At this point, I can go ahead and hit create report and get an automatic PDF report created for me. The report that I'm about to showcase to you, I've personally charged in my consulting life $15,000 to $20,000 for. Of course, you can create as many of these as you like for as many projects as you like. So it gives me the site address, my walk score, bike score, transit score. It gives me my whole building EY, what my baseline was. It's done with the California Title 24 2019, and it's better than the national average. It tells me what the benchmarks are for national averages for my baseline and targets for energy, daylight, and glare. It showcases all of the energy analysis for me. It also tells me personalized recommendations of exactly what I can do to push my building's energy use even lower. I can see all of the water use analysis as well for indoor, outdoor, and stormwater usage, something I haven't even touched on yet. I can also see the 2030 palette case studies. These are all location adjusted and building type adjusted for your project. A really, really great way to present some strategies to your clients and owners in charrettes, in early meetings, to make sure that everybody is definitely aligned on strategy and on the same page in what some of the things that can work for the project. All of the climate analysis pulled together along with good action items and next steps. For example, the psychrometric chart tells us right here that 3% of the time is comfortable without any passive strategies. However, if we add some internal heat gain, we can increase our comfort by 60%. So we want to attract all that heat for the San Francisco climate. All of the climate wind analysis broken out by the month. I can download the PDF and go ahead and add my firm colors, my firm logos, and really be on my way. While all of this is absolutely fantastic, perhaps you want to take it to the next level and do a really detailed energy model with your energy consultants. You're able to hit the Open Studio Export, which will give you a compliance-ready energy model that you can modify with your energy code energy consultants, with your mechanical engineers, where the same model that you've drawn as architects will open up in the software that they use for detailed energy modeling as well. So again, saving everybody on the team tons and tons of time, easily 60 to 120 of remodeling time that I've personally spent on my team. Once we've done all of this, we can of course take a quick peek at the water use studies as well, just like I pointed out, and test out low flow fixtures. Maybe it's not quite that low flow. Perhaps gray water got scrapped from the project. We can remove it. We can understand how much water we'll be using from an irrigation standpoint. Maybe instead of native plants, we want to use garden agriculture, see what that does to our water use. Maybe we want to use some sprinklers, see what that does to our water use, so we can really tie the entire design together. The goal and the benefit that you have from having an integrated workflow with your entire team is, for example, if your design has great daylight, you'll see that your design will use less lighting energy load because it's all connected. If you're using low flow fixtures for your water use intensity, you'll see that in your overall domestic hot water usage, the amount of energy it takes to heat up the water is lower because it essentially is less water. Some of these things never get coordinated or matched because everybody is kind of working in their unique silos. So just bringing everybody together using the same basis of design really helps alleviate that. Um, Another part of the analysis, which is my personal favorite, which we talked about early on, is the cost versus energy optimization. You get there just by clicking here, and it will bring you to a screen that looks just like this. I know this is a whole bunch of squiggly lines, but it will make a whole lot more sense in just a second. Each vertical axis is one possible decision where we have glazing, 3 types of glazing. Wall, we have 4 different wall types. Roof with multiple different wall options. These are all different products, and we're balancing all of these against potential lead points if we care about it. Embodied carbon, because we can also balance out support structure, which has an immense impact on the entire embodied carbon picture. Cost premium, the money that we have to pay up front, payback years, and energy savings. Each blue line is one possible scenario. So for example, if we're working on a project and the owner tells us to take out any options that are more than 5 years of payback, we can simply do that. We will remove all options that are more than 5 years of payback. Now within this, if we want to get to at least 20% energy savings, we can see the options that remain. Within those, if we're wanting to get to a medium or low embodied carbon, we can see the absolute lowest cost way to be able to do that. So we can actually save $17,000 from base minimum while hitting 21% energy savings. And it tells us exactly how to do that. For example, in this case, it's telling us to not spend any more money on the walls. It's telling us to use this code minimum glass. It is telling us to upgrade our roof and upgrade our mechanical systems, along with adding some solar panels. So that seems to be the best way out. So look for the scenarios that make most sense to you, that are prevalent to your project, and you'll be able to optimize your particular project as well. Now, you can customize exactly what these options are by simply hovering over these tabs, and you can simply add and remove options. You can create custom options or select from a list of drop-down. This is exactly the process that this particular team did for the third classroom and engineering building. This is a University System of Maryland project designed by Cooper Carey architects and AEI engineers. It's a 75,000 square foot building composed of classroom, lab, and dining building. This particular project, which we can see the rendering in the background, courtesy of Cooper Carey, had pretty good performance goals. They wanted to do 30% better than industry benchmarks. They set up realistic performance goals that they were definitely going to try to hit. They wanted to have daylight over 55% of spatial daylight autonomy. So that basically means over 55% of the floor plate could operate without any electrical lighting. They wanted to have glare under 10% to make sure that less than 10% of their floor plate would have glare-related challenges. Again, just goals to make sure that the building was going to pursue and be a high-performance building that occupants would enjoy being in. Now, for this lab project, the design team started with understanding the climate a little bit better by using all of these climate analysis, as we just saw how to run them. They were utilizing this in the concept design phase to understand what the climate was, understand which passive strategies were even going to work for this particular project. For example, again, internal heat gain was going to be a big one, along with dehumidification for this particular project because it's in Maryland, so it made a big difference. Understanding the benchmarking was core to this particular design team because they wanted to make sure the targets they laid out were realistic. So the national average was 100 EY for this project. This team wanted to get to 60 to 70 EY, even though the 2030 target was 30. They consolidated that with the feedback from the ownership team that wanted to definitely move away from just hitting a national average, but we're definitely not in a position to be ambitious to go as low as the 2030 targets. Of course, completely possible, completely valid, but sometimes we just have to pick and choose which clients we can push that far with us to help solve this climate change problem. They were able to also look at the benchmarking for daylight and glare and set some of those targets. Then came the schematic design phase. This particular design team was very iterative. They did tons and tons of sketches, tons and tons of designs, tons and tons of overviews. As you can see, there's a whole range of different design schemes. Each of these are different plan views, different organization on how they could put the same program elements on the site to figure out the best way to do that. With every design scheme for every single design meeting, the team always presented an energy and a daylight number as well, in addition to what it meant in terms of aesthetics, what it meant in terms of some of the other core elements, the zoning, the site, the master planning, but also energy and daylight. Other teams have taken this a step further and built in views because it's right there. It's so easy to do. Or even radiation mapping to see how that compares, or shadow mapping to see how that compares. But this team made sure that there was no design meeting where design options were being considered where the holistic picture was not presented. So when they showed this to the actual owners, it was quite obvious that option 2 is the best performance in terms of energy. We can see it's got the lowest energy use. Even though it's got a pretty okay daylight, it's not got the best daylight, it's not got the worst daylight. So it was immediately obvious that option 1 was just not going to work. So that was easy to leave out. Then came it between option 2 and 3. And because daylighting was such a core part of this particular design team and the design aesthetic and what the ownership was trying to do, they went with option 3, knowing that it was a little bit more energy, but they knew that at schematic design so that they could use the remainder of the design phases to make sure that they can balance it out. Information is key. Information is what helps us make good decisions. So they knew that they were going to have some energy challenges, so they definitely needed to balance those, but they would have a much higher exposure to daylight, which was a key deciding factor. So they went with this particular design scheme and then moved on to the optimization phase for design development. They looked at 3 different types of roof options. these three different SNX, all of these three different glass products from different manufacturers, different wall assembly options, sensors, lighting types, set points, different mechanical systems, and all of these together are 864 possible combinations. There is no way that a particular team can study that many options manually and still meet the budget and still make a profit or even break even on any given project. So they used the optimization just like we saw. They used sliders to find the cheapest way, the lowest cost way to get to an EUI of 75, the lowest cost way to get to 65, and the lowest cost way to get to 55. Once they did that, they were able to present those options, showcase those options to the ownership team who was able to decide for the lowest cost option to get to 55. They were able to get that buy-in from the ownership team because that was part of their original pursuit. That was part of their original design. They kept the continuity through so that there was no room for being surprised and everybody was bought into the same mission and had the same goals for the actual project. Holistically, this design team could have easily spent 235 hours or $32,000 on doing all of the analysis that we just saw. But of course, with the optimization, they spent 3 hours in concept design, 4 hours in schematic design, 2 hours in design development, and 1 hour in construction drawing phase, bringing it to a sum total of 10 hours per project, with their average billable time being at 150. That was $1,500 a project. No matter how big or small our project is, every project can afford 10 hours of billable time to make sure that our entire building performance, holistic building performance strategy is all tapped in and is all ready to go, which is exactly why we get to do this, not for that one elite, one special project where we have budget for it, but on 100% of our projects, which is exactly what we need to do to fight our existential crisis of climate change. The same process applies to every single building type, and that's exactly what we see with our users on the platform, whether it's new construction or renovation projects, whether it's a multifamily or a single family, whether it's labs or it's healthcare. We can all go ahead and start incorporating a lot of these strategies directly into our designs. That's a little bit high level of some of the information that I brought with me to showcase to all of you today. I'm going to go ahead. There's a few things that I'm happy to showcase still, but I definitely want to make sure I leave time to answer some of the questions that have come in. So I'm going to pop open these questions so I can start answering some of them. So one question that came in was, can you clarify the email address and message to send to extend the trial? You can send that to hello, like as in literally hello, at cove.tool.com, along with the certificate for the actual event, and the team will be able to automatically extend that for you. Another question that came up was, are you able to save or lock your views for consistent repetitive diagrams from a given orientation? You definitely are able to. So wherever you leave it is exactly where it will be. For example, right here, if this is where I left it at and I exit out of this project, or I invite a team member to collaborate with me on the same project, this is exactly the view that they will see too. However, if I'm also collaborating with my team member, which I am invariably for every single project, I can also just lock the project so that they can't make changes to it, which also makes the process much, much easier. Hopefully I was able to answer your question. Another question that came up was, does that work for Revit LT too? I do not believe it works for Revit LT. I can talk a little bit more about the versions that are supported as part of the App Store. So here we are on the App Store, where there's a whole range of different types of plugins that are available. Everything from SketchUp, Rhinoceros, Revit, Grasshopper, Blender, BIM, ArchiCAD, Giraffe, Vectorworks, AutoCase, so on and so forth. So it plugs in with all of those in Revit in particular, since that's the question was about. It works with a whole range of different compatible versions. You can download the latest version of each plugin also directly from the App Store. Another question that came up was, does it have heat island effect analysis? You are definitely able to modify the the reflectance of your materiality to make sure that you're incorporating the heat island effect, but it is very well part of the entire picture because it gets your context automatically and it understands your local weather conditions automatically as well. So you are very well, you can change the reflectance values and see the effect on that in terms of the heat island effect as well. Another question that came up was, how does cove.tool determine the quality of a view? Example, view of a landscape, water versus window facing a utility yard. Great question. It doesn't. It just tells you if you can see anything to the outside. However, a designer can add an extra layer to it, and perhaps, perhaps this view is to some trash cans or a utility. I certainly hope not, because it's prime real estate next to the marina. But if that was the case, you certainly could be able to rate that yourselves. What it does do is it tells you, do you even have a view? Can you see out? Is it blocked by something? Is there a building right in front of it so you can't look too far? Or, is the window too small that humans can't even look out of it? That's the analysis it does. However, you're able to go in and further say, you use this and be like, all of our high, like, elite views or views to the mountain are deep yellow. That means they are able to look out instead of all of the mountain views being the gray non-view zones. Another question that came up was, I'm curious how your tool compares to competitors' tools if they exist. The key competitor, in my opinion, as I realized when we started developing cove.tool, is truly just doing all of this manually, which you can. You can do bunch of these pieces of analysis in a whole range in 5 to 6 different platforms. And it would take you about 250 hours to do it. There's really no way to do view analysis, which we're on right now, unless you're a scripter and an experienced grasshopper modeler, which again, there's not that many of. But it really does provide accessibility, saves you tons of time, allows you to do unique analysis types that don't exist even in any of the 5 to 6 different platforms that you can pull together to do some of this work. But same is true for the optimization. None of this analysis type is available in just about anything else. You would have had to do it manually, again, spend tons of that time. Another question that came up was, what is used to calculate the cost-benefit analysis? So the cost versus energy optimization is done for the elements that you define. So this is our parametric studies, where you can go in, you can, for example, wall, I can define multiple different types of wall. I can do so from a drop-down, select a product, it updates the R value, it adds the cost information, which is provided to us by the manufacturers, and then location adjusted for you depending on where your project is, and also the embodied carbon value, which is pulled in directly from the EC3 database. Again, if you have a cost estimator on your project, or perhaps if you have better, more project-specific cost data, you can simply modify this. Maybe this is $7. You can completely change that to match the needs of your particular project. Once you've defined all of these, you're able to hit recalculate, and it's able to run through every iteration to find out the lowest cost way. It's running the machine learning algorithm to find the lowest cost way to hit your performance targets. Another question that came up was, does it evaluate internal views as well, such as courtyards? Absolutely. If it's an opening, if it's modeled accurately in a 3D model, you're very well able to do that as well. Another question that came up was, is there an educational/student version available? We do offer a whole year of complimentary licenses for all academic work for students. You can apply for it simply by going over, let me actually show you the steps for any of the students that may be online. You can hit buy now. And I know that students are not buying it, but you can go for right here. There we go. The student professor license, there's an application, you can fill it out and you can get your student access or your professor access. It is being taught in over 200 universities as we speak, so there's tons of students and professors that are already on the platform. Another question that came up was, what is the COVID analysis type? Absolutely, the COVID analysis type allows us to look through, so here's the simple geometry that I modeled in the drawing tool. So maybe you'll draw something a little bit better than me. But This particular analysis type helps us figure out how much of the floor plate is able to maintain 6-foot social distancing. And for every analysis type similar to this one, you can actually click on the question mark and hit learn more, which brings us back to our internal help center, our Google for building performance, which describes to us exactly what this analysis type even is. For example, this is taken directly from the AIA reoccupancy assessment tool and the lead safety pilot credit. It walks through the exact calculation methodology along with giving some of the obstruction calculations and case studies. For example, here's how one office building used it. They brought in all of their furniture as well using the interior wall layer under Revit, and they were able to see that, well, the current furniture layout was just not going to fly because people weren't going to be able to meet their 6-foot social distancing requirement as recommended by CDC. And they knew that for the same space where they could once hold over 550 people, they can now only hold 355 people. So it also updates your occupancy calculations along with giving you a gradient in terms of risky to safe. The same analysis type can be used for restaurants and, like to figure out the walkways, or classrooms to figure out how many students you can safely fit in a given classroom. This classroom that can now have option C is the best one, right? Because we did A versus B versus C. It could once have up to 18 students, but can now support only 7. Another question that came up was, what liability does cove.tool have for errors in data calculations? cove.tool carries the same liability for errors in data calculation like any other building performance analysis tool. To put it even more explicitly, none. That is true of the entire building performance analysis space and industry, because it's really hard to predict how a building is going to be built. I might put in cove.tool that my building will operate 8 a.m. to 5 p.m. and I'll have 50 people, but perhaps when it's operational, maybe someone wants to stay late, maybe Bob or Rob or somebody else wants to work till 9 p.m. every day and leaves the lights on, and it just throws off our energy use. Maybe when it was getting built, like a little infiltration, like a hole got left, or a part of insulation got left, which happens all the time. And for that reason, this is true of not just cove.tool, this is true of every single building performance platform that exists in the world today. Another question that came up was, does 2030 DDX recognize cove.tool as a modeling engine? It certainly does. You're also able to not only model, you can auto report. So as part of every single project, once you're, gosh, I have so many screens open, there we go. So you can actually report your projects directly to the AIA 2030 by simply clicking the 2030 icon, and it goes and reports automatically, and it is completely recognized by the DDX. We're also listed on the DDX website. Another question that came up was, many energy simulation programs have the difficulty with modeling passive solar impact. Protections are usually pretty good, but internal gains are more challenging and to model accurately. Any innovation with cove.tool on this? So cove.tool definitely uses the heat balance systems, and you're completely able to modify all of your internal gains as well, but it still uses the heat balance methodology, which is used by platforms like Energy Plus or eQuest. The benefit of cove.tool, however, is that because it is a smart platform and we have over 10,000 users modeling 15,000 projects as of now, we're able to learn from all of our users. For example, if there are certain use types, if there are certain inputs that are more prevalent in a location, we're able to learn from it. We're able to make sure that the platform actually keeps getting better with more usage instead of stay stagnant, which is true of pretty much every single legacy platform. Hopefully that answered your question.
So that sounds like the end of the questions there, Sandeep, huh?
It certainly does.
There was a couple in the chat box. Angela had their hand raised and Stephen had a question. Angela, did you still have one?
Well, while we kind of figured that out, one of the other questions that came up was, what is the cost of cove.tool? So again, just like no one shoe size fits all, we definitely Our goal is to fight climate change, and we do so by making sure that cove.tool is as accessible to a one-person firm as it is to a 1,000-person firm. And because of that, you're able to actually understand exactly what best meets your needs by going over to Buy Now, and it'll just make you hop on a quick 10-minute call so our team can understand a little bit better about your needs and propose the best plan for you so that the single person firm with sole user can afford it, and the 1,000-person firm with 1,000 users can afford it. So it's definitely designed to be affordable so that you can pay it off in less than one project. Most of our users paid off in just the trial period, which is of course also extremely helpful. While additional questions are popping in, I did want to showcase one additional aspect that's an analysis type that's immensely helpful for architects, especially for the early stages of design. It's like a massing analysis, because a lot of us are people that like to iterate. We try to do, tons of different options, which is exactly what the Bowser Walker team did for the Georgia Tech Public Safety Facility. So just letting it load up here. That's kind of what will happen in any kind of a live demo. But I'm basically able to model my project just like we did, create a copy of it, update the geometry, and leave everything else as is, create another copy of it, and upload the geometry, and basically create this comparative analysis. And let me showcase that actually under the Help Center. So there we go. And so, of course, mechanical engineers use that too to do basically their mechanical engineering, and basically you're able to hit on those projects and do A versus B versus C and get a really, really quick overview on how they compare to, again, save us tons of time to make sure that we're able to compare options iteratively. That is everything I wanted to show today.
That's great. Did we find out one person that had a question that didn't get?
They're on. Oh, there she goes. Are you there? Are there any other questions?
Well, hearing none, I want to give a huge, big thank you again to Sandeep and to cove.tool for this outstanding presentation. I just totally loved your enthusiasm and obviously your passion for this topic. Thank you.
I appreciate you and everybody that's attending. It's been such a pleasure answering your questions and presenting to you.
Yeah, looks like we had close to 70 people or more. What a great turnout. So if you've all of you have made it this far, the AIA California staff will submit for your AIA CE credit, and it should appear in your transcript in a few weeks. As mentioned, AIA California members will have the opportunity to receive a 4-week complimentary license and additional support, and you sign up before April 30th to take advantage of this AIA California member benefit. And there are more resources and tools can be found on the AIACA's website, which is aiacalifornia.org/member-benefits. And more details on the 2021 Climate Action webinar series will be shared with all of you via email. So thank you again for joining us today, and we will see you at our next Climate Action webinar. Thanks, everyone.
Thank you.
Bye, team.